Hello everyone, welcome to this new series of math puzzles. आज हम एक इंटरेस्टिंग मैथ प्रॉब्लम सॉल्व करेंगे. प्रॉब्लम है समेशन ऑफ n बाई 2 to the power n. इसमें n है फ्रॉम 1 to infinity and we need to solve and find a closed form for this expression. So can you guys guess what would be the answer for this expression? And can you solve it for a closed form? Okay, so let's start solving this by expanding this expression. तो हमारे स्टार्ट में समथिंग लाइक दिस 1/2 प्लस 2/2 to the power 2 plus 3/2 to the power 3 plus 4/2 to the power 4 plus till infinity. Okay, so to simplify this expression, let's assume 1/2 is equals to x. Okay, so now our expression will be something like x plus 2x square plus 3x cube plus 4x to the power 4 plus till infinity. Okay, so we can have x common from this expression. So the series would be 1 plus 2x plus 3x square plus 4x cube plus till infinity. Okay, so now one can notice that in this series there is something common for each term. So if you say for first, so it's 1, second is 2x, third is 3x square, 4x cube. So you can find some mathematical property, some mathematical concept here. So let me remind you something. So if you have learned about the differentiation, so one is differentiation of x with respect to x. Okay, so let me write it. अगर ऐसे लिखें d/dx for x, so it would be 1. d/dx for x square, it would be 2x. So यहाँ पे similarly d/dx for x cube, so that would be 3x square. So यहाँ पे हम ये देख सकते हैं कि ये सीरीज इज नथिंग बट d/dx summation of x to the power n, where n begins from 1 to infinity, right? ये हमारा एक्सप्रेशन बना. इसको let me correct it. Okay, so अब इसको हम सॉल्व करते हैं. समेशन ऑफ x to the power n, this is a geometric progression. Summation of geometric progression, you guys should always you guys should already know. And if you don't know about geometric progression and infinite geometric progression, we can have another video explaining those. So please let me know in comment section so that I can make another video on infinite geometric progression. Okay, so let's solve this first. So first let me solve for this geometric progression summation, right? Then we will differentiate that. So geometric progression would be x plus x square plus x cube plus, so here common ratio is x, and first term is x, right? If first term is x, common ratio is also x, and what x is? X is 1 by 2. So the sum equals a, which is x. I mean, a means first term, so first term is x into 1 minus common ratio to the power infinity, to the power infinity by 1 minus x, right? So let me tell you something about infinite geometric progression sum. So here, since common ratio is x and x is less than 1, because x is 1 by 2, so this series is a converging infinite series. So what does mean by converging? So it is converging to 0, as so let me tell you. So we can write it something like x minus x to the power infinity, as infinity plus 1 is again infinity. So let's write something like this: 1 minus x, right? Okay, so x is 1 by 2 to the power infinity. So 1 to the power infinity would be 1, and 2 to the power infinity is significantly large. So this value would be 0, right? This is tending to almost 0. So we are assuming it 0, and we can safely ignore this part. Okay, so GP sum would be x by 1 minus x, right? As first term is also x, and the common ratio is also x. So our sum, geometric progression sum, would be x by 1 minus x. So let me put this into this expression. So it would be d by dx, and this x by 1 minus x. Okay, so x. Now if you guys are aware about the quotient rule of differentiation, then you would be easily solve this differentiation. So let me write it currently. So it would be 1 by 1 minus x whole square. So this is the differentiation of this x by 1 minus x. Okay, so now you have a simple expression in terms of x, and you already know the value of x, so you simply put the value of x into this, and you will get the answer. So it is 1 by 2 into 1 by 1 minus 1 by 2 whole square. So that would be 1 by 2 into 1 by 4, so it would be 2. Okay, so final answer is 2. So the closed form of summation of n by 2 to the power n, where n is from 1 to infinity, closed form of this expression would be 2. So this is quite interesting problem, considering the concepts and mathematical intuition this question is this question is having lots of potential to hit on lots of mathematical concepts, as we get to see here: differentiation, then again geometric progression, infinite geometric progression. Why the in this infinite geometric progression is converging to some value. So here common ratio is less than 1, that is why it is converging to this one, x by 1 minus x, right? So question for you guys is, what happens if common ratio is greater than or equals to 1? Okay, so you can also let me know in comment section uh, if you have any doubt, or if you guys are interested in knowing the concepts of uh, infinite geometric progression or differentiation, or any mathematical uh, series, or any interesting questions you guys want to know, please let me in comment section. And if you like the video, please hit the bell icon and subscribe to